Okay, so we're going to continue in this section on quadratic functions. We've already talked about completing the square and getting a quadratic function into the vertex form. So now, this is what we finished up doing last time, was we wrote this equation in vertex form, and after we had it in vertex form, this is kind of a real quick review, after we had it in vertex form, then we were able to graph it, opens up, opens down, where's the y-intercept, and a lot of information. So we learned that the vertex form is really handy. So today what we're going to do is talk about what can we do with the quadratic function when it's not in vertex form. I mean, we can't just throw it out. We're going to be able to also use the standard form of the equation in some select ways. And so this is the standard form. So now we're going back and saying we don't have to trash the standard form. We can also use it. So in part C, it says, given the quadratic function standard form, notice sometimes we have one x-intercept, which remember they now call zeros of the function. We can have two x-intercepts to our parabola, or no x-intercepts to our parabola. So for example, if we have one x-intercept, we could have a graph that looks something like this, where it just touches the x-axis in one point. So that would be an example of having one x-intercept. So what it says here is that if you compute b squared minus 4ac and it ends up equaling 0, then you will have one x-intercept. So your parabola will look something like that. It might be opening down and be under the x-axis, but it's just going to touch it. If you have two x-intercepts, that's kind of what we normally see. It's something like this, where you cross the x-axis in two places. So there's an example of a parabola having two x-intercepts. And what it says here is if you compute b squared minus 4ac and it's greater than 0, which means it is positive, it is a positive number, then you will have two x-intercepts. Okay, so when we do some examples of this, it will make more sense. But if this value is a positive number, then you will have two x-intercepts. No x-intercepts would be an example like this, where you're above or always below the x-axis and you don't ever touch the x-axis. That would be where you have no x-intercepts, and you can compute this expression b squared minus 4ac, and if it is negative, then that would tell you that you're not going to have any x-intercepts. So what they're going to do is they're going to say, okay, how many x-intercepts does this quadratic function have? And you're going to come in here and you're going to compute b squared minus 4ac. If it equals 0, you have one x-intercept. If it's positive, you have two x-intercepts. And if it's negative, you have no x-intercepts. So that's where this is going. Here's the kind of question. Determine the number of solutions or x-intercepts that this quadratic function has. So without graphing it, without finding the x-intercepts, we're just going to say it's either none or 2 or 1. Okay, so to get that answer, we come in here and we say, okay, I'm supposed to do this b squared minus 4ac thing. Okay, what is b and what is a and what is c? Well, when you have this equation in standard form, the 3 is your value of a, the 12 is your value for b, and the 5 is your value of c. So then you come over here and you actually compute b squared minus 4ac, which is going to be your 12 squared minus 4 times 3 times 5, which is 144 minus 4 times 3 is 12, and 12 times 5 is 60, and this is going to equal some number, and it's going to be a positive number. And if it's positive, according to what was written above, positive means two x-intercepts. Okay, so if this is a positive number, it could be positive 1, it could be positive 1,000. If it's just a positive number, then I can conclude that if I were to graph this f of x, it would have two x-intercepts. I have no clue where they are, but I can tell you right now that it will have two x-intercepts simply by computing the b squared minus 4ac. So that's the answer to the question. It will have two x-intercepts. I don't know what they are, but there's going to be two of them. Okay, so let's try another one. Same question, determine the number of x-intercepts or solutions that part B this function is going to have. I have no clue, but I do know that A is -1, B is -4, and C is -5. So I come over here and I compute B squared minus 4AC. Okay, B squared would be a -4 squared minus 4 times A times C, and be sure you get that B is a -4 and C is a -5. So this is a positive 16 minus 4 times -1 is -4, and -4 times -5 is positive 20. So this becomes a negative value. I don't care how big the negative value is, it's just if that thing is negative, according to the above notes, that means what? One solution, two solutions, or no? No solution. So in other words, well, no solutions or no x-intercepts. I'm going to put no x-intercepts. All right, and I think there's one more. Yeah, here's one more example. Again, the same question. In this case, A is 25, a pretty big number. B is a -20. And C is a positive 4. Again, you're just computing the B squared minus 4AC. So this is going to be B, a huge number, -20 squared, minus 4 times 25 times another 4. These are big numbers. This is 400 minus, 4 times 25 is 100, times 4 is 400. So this one equals 0. So if it equals 0, what does that mean? One x-intercept. Anybody ever heard of this B squared minus 4AC? Does that sound familiar at all?
Yeah.
The quadratic formula, right? This is coming from the quadratic formula, because if you remember, and this, this is just a little bit of information. If you remember, the quadratic formula was -b plus minus the square root of B squared minus 4AC over 2A. So this B squared minus 4AC is what's going underneath the square root. So if you have to take the square root, like here on part B, if you take the square root of a -4, that's undefined, so there's not going to be any x-intercepts. If you take the square root of 0, it's 0, which is one value, which is one x-intercept. If you take the square root of something like 84, it's going to be plus minus the square root of 84, which is two values, or two x-intercepts. So that's really where it all comes into play. They don't explain all that. They just say, use this B squared minus 4AC to answer these questions. And that's all we do. So just be very careful with the negatives when you square them, when you're subtracting. Be careful with those so that you don't get something like that incorrect. All right, so now it says, part D, find the vertex of your parabola. And remember, parabolas, we have so many words. Parabolas are also our quadratic functions. Okay, our quadratic functions, we just kind of informally call them parabolas. Find the vertex of our parabola by using the vertex formula. Okay, so in other words, we're going to find the vertex given the standard form of the equation, in which we're not going to bother to do the entire algebraic method of completing the square. So we're going to find another way of getting the vertex without having to do the process of completing the square. And so it says when your parabola is in this standard form, then the x-coordinate of the vertex is this. So your vertex, the x value of the ordered pair of your vertex, the x value of the vertex of your parabola is going to be -b over 2a. That is the x value of the vertex of your parabola. So once you get the x value, then you plug it back into the equation to come up with the y, which is what this lovely notation is, this huge negative b over 2a and f negative b over 2a. That's the y value. So once you get the x, you plug it back in to get the y. All right, so let's take a look at this. Let's take a look. So negative b over 2a is one of those things you just have to memorize. So given that f of x is negative 3x squared plus 12x minus 8, this sucker is in standard form. And I'm not going to complete the square to get it in vertex form. I'm going to leave it like that. Determine the vertex. So we've got to find the vertex by using this vertex formula. And when you see this word, this is this negative b over 2a step. The vertex formula is the negative b over 2a. And after you do that, find the y-intercept and the axis of symmetry and sketch the graph. Okay, so here we go. So if we have, and I don't know, I can take it out of function notation. If this is my function, and I already know that a is negative 3 and b is 12, and I don't have to have c to use this vertex formula because I know the x value of the vertex, if I get this memorized, is negative b over 2a. So this is a negative of a b value of 12 over 2 times an a value of negative 3. So it's a negative 12 over a negative 6, which is a positive 2. So what that means is I now have the x value of the vertex of this parabola. So right now my vertex is an ordered pair and the x value is 2. What do you think the y value is going to be? How could we find the y value? Just plug it back in. That's right. So it's kind of like saying if we drew a table and we now know that we need to use an x value of 2, plug it in and get the y value. Okay, so the y value is going to equal a negative 3 times 2 squared plus 12 times 2 minus 8. So that's a negative 3 times 4, which is a negative 12 plus 24 minus 8. And so that's going to equal, what, 12 minus 8, which is 4, right? So my y value is 4. So my vertex, without having to complete the square, my vertex is the point 2, 4, which is pretty handy. Okay, so now it's going to ask me a whole bunch of other questions, but let's think about this. Let's think about this. Looking at my equation, is this one going to open up or down? There you go. Since this is a negative leading coefficient, I know that this is going to open down. Can y'all just look at this vertex and tell me what the axis of symmetry is? What is it? X equaling 2. That's that vertical line, right? So without even graphing it, you can sort of maybe visualize it so far. And so of all these questions, find the vertex, find the axis of symmetry, graph it. One more thing, they want me to find the y-intercept. Okay, they want me to find the y-intercept. So the y-intercept occurs when the x value is 0. So this is your y-intercept. And the vertex is the first ordered pair we found, which was 2, 4. Okay, so to find the y-intercept, okay, I go back to my original equation, y equaling a negative 3x squared plus 12x minus 8, and I put an x value of 0 in. And when I do that, my y value is negative 8. So I have my y-intercept. These two things are what created my vertex. And they want me to sketch it, and I don't know where in the world I'm going to sketch it. I didn't give myself a lot of room. I guess I'll try to sketch it over here. Okay, so I have what? 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Way down there. So I have 2, 4, and it's got a y-intercept down here of 0, negative 8. And so over here by symmetry will be another point, and the graph will look something like this. And here is its axis of symmetry, coming right down the middle. So we can still get a lot of information even when it's in standard form. It's pretty amazing. We get the vertex. We already got this up, down, opening up and down stuff. We already know the axis of symmetry from doing the other. We have now the y-intercept, and we have the graph. Okay, so the big thing is you have to memorize, and you can't forget it or you're really stuck. I mean, you're lost here if you don't have memorized that the x value of the vertex is negative b over 2a. That's what you have to memorize or you're lost. You're really stuck here if you don't know that. Okay, so let's try another one. Same kind of thing. Here is a parabola because it has an x squared term in it. I'm supposed to find the vertex. Then I'm supposed to determine if it opens up or down. Then I need to come up with the axis of symmetry and then the y-intercept. Okay, so if it is y equaling 2x squared plus 4x plus 5, then my a is 2 and my b is 4. And I only need the b and the a in order to get the vertex by the vertex formula. So the x value of the vertex, which I need to memorize, is negative b over 2a. Well, that is a negative 4 over 2 times 2, which is just a negative 1. So the x value of the vertex is a negative 1. So if I kind of look at this as a table, right now my vertex is the point where the x value is negative 1, and I need to get the y value that goes with it. So to get the y value, and this is a negative number, we're going to have to square it, so be very careful. The y value is 2 times negative 1 squared plus 4 times negative 1 plus 5. So that's 2 times a positive 1 minus 4 plus 5. So that's a negative 2 plus 5, which is a positive 3. So the y value of the vertex is 3. So this vertex is the point negative 1, 3. Once you have the vertex, you're ready to go now. Okay, we're really got a lot now we can work with. So looking at the original function with this leading coefficient of 2, positive 2, is this thing going to open up or down? Opens up. What is my axis of symmetry? Boy, you are quick. I can't even write it as fast as you can answer it. Okay. Okay, and the other thing they were asking is what is the y-intercept? Okay, so the y-intercept is the point where the x value is 0. So it's again like a table of values over here. And now I need to get the y-intercept. And in standard form, we've already talked about that's the easiest way to get this one. So it's 2 times 0 squared plus 4 times 0 plus 5. So with the y-intercept, the y value at the y-intercept is 0, 5. So we have the y-intercept, we have the vertex, we have the fact that it opens up, we have the axis of symmetry, and we should be able to graph it. Okay, let's see if I can make a drawing of it over here. Negative 1, 1, 2, 3, 4, 5. So at negative 1, 3, that's my vertex. It's going through 0, 5, so a mirror image will be over here. And it's opening up, so it looks like this. And it has an axis of symmetry right here at x equaling negative 1. Everybody doing okay? Okay, one more like that. We're going to be good at this. Same thing. So it's in standard form. Y equals a negative x squared plus 6x. First thing I'm looking for is the vertex. You have to remember, you have to have this memorized, negative b over 2a. Okay, so a is negative 1 and b is 6. So my x value of my vertex is a negative 6 over 2 times a negative 1. So negative 6 over negative 2 is a positive 3. So the x value of my vertex is a positive 3. So again, this is kind of like having a table of values, x and y. I have my vertex. Now knowing that the x value of my vertex is 3. To get the y value of the vertex, I go back to my original equation. Be careful with all this squaring. The 3 is being squared, not the negative. The negative is still on this equation. Plus 6 times 3. So this is a negative. 3 squared is 9. So this is a negative of a 9 plus 18. So this turns out to be a positive 9. So my vertex is the point 3, 9. Looking at the original equation, it has a leading coefficient of negative 1. So does it open up or down? Opens down. And the axis of symmetry is x equaling 3. The vertical line, the equation of a vertical line is always an x equals. Okay, and they're also going to ask me for the y-intercept, which is pretty easy in standard form. So you're going to have y equaling a negative 0 squared plus 6 times 0, which is 0 plus 0, which is 0. So don't get all your zeros confused. This is the y value of the ordered pair. So the origin is your y-intercept. Okay, so I might have difficulty graphing this one in this little bitty space I have. I will try. Okay, so 3, 9 is way up here. Thank goodness it opens down. Going through the origin, right? What is this other point? Here's my axis of symmetry. What's the other x-intercept? When I do the reflection of the origin over that axis of symmetry, what's going to be the name of that point? It's going to be a 6, right? Oh, and it's not supposed to be pointed up there. There's your graph. Okay, so we do not have to put it in vertex form to find the vertex, but we do have to memorize that x is negative b over 2a. Now I'm going to scroll up here and look at some notation. This notation is kind of intimidating. Right here, it says the vertex is given by, this is really ugly, right? We know that this is the x value of the vertex, the negative b over 2a. So what are they doing when they say f of negative b over 2a? Right, that's just the function notation, right, of that x value that you find. Right, so you find x by throwing the negative b over 2a in there and getting the value, and then the function notation says to find the y value by inserting that x value you found. So that's just a big old function notation ordered pair. All right, now you know how to do it, and you really don't have to worry about that notation. I just wanted to kind of go back and look at it for a minute to see if you can kind of understand what they're showing you. All right, so now what? Oh boy, okay, here we go. Here we go. We're solving applications. These are the word problems. Do not panic. These word problems sound terrible, but do not panic. Okay, your numbers are not going to be beautiful values anymore because they're real applications, and so they're not going to be nice, pretty numbers. Okay, but it's going to be all right. So the one thing you have to remember when you're doing an application with quadratics is if your parabola opens up, the vertex, which is that all-powerful point, is a minimum. But if your parabola opens down, your vertex is a maximum. So when they get into these word problems, they're either maximizing something or they're minimizing something, which means your goal is to find the vertex. Okay, so your goal is going to be to find the vertex, because the vertex is either going to be the maximum or the minimum. And you know how to find the vertex. The x value of the vertex is the negative b over 2a stuff that we just discussed. But the numbers are not going to be pretty numbers anymore because these are real applications. All right, so that's just trying to prep you for what you're getting ready to see. These sound terrible. A stone is thrown from a 100-meter cliff at an initial speed of 20 meters per second and at an angle of 30 degrees to the horizontal. The height of the stone can be modeled by, oh my, look at that lovely equation. Okay, no panic, whatever. They used all that information I just read, the 100 and the 20 and the 30. They used that information to create this function. Is this a parabola? Do you see something squared? Yeah. And is it going to open up or down? Down. There you go. It's going to be a parabola opening down. So guess what? I bet there's going to be something about maximizing something because the vertex will be a maximum. So the height is in meter and the time is in seconds after the stone is released. Determine the time at which the stone, there it is, will be at its maximum height. So find the vertex, because you know the vertex is going to be the maximum. If this thing is opening down, we need the vertex, which is going to be the maximum. Okay, so here we go. To find the vertex, we know the x value of the vertex is negative b over 2a. Okay, look up there at that really pretty bad looking equation, right? Well, if I take it out of the h's and the t's and write it as y's and x's, this would be y equaling a negative 4.9x squared plus 10x plus 100. That's all it is. They're just using different variables. T is replacing our x, and h of t is replacing our y. That's all they're doing. So in this case, my a is a negative 4.9, and my b is 10. So my x value of my vertex is a negative 10 over 2 times a negative 4.9. Well, a negative over a negative, this is a positive value. So I'm going to take 10 and I'm going to divide it by 2 times 4.9. And I'm not even going to fool with the negatives. I just know that the negative over the positive, the negative over the negative is going to be a positive result. And what did it say? Round it to 2 decimal places. So I'm getting a 1.02. I'm getting a 1.02. So my vertex is now 1.02, and I need the y value. So now to find the y value of the vertex, I put that 1.02 into this equation. So it's a negative 4.9 times 1.02 squared plus 10 times 1.02 plus 100. So if you put all of that in your calculator, negative 4.9 times 1.02 squared plus 10 times 1.02 plus 100, I get 105.10. So my vertex is 105.10. Okay, so this vertex on this little diagram I drew over here, I could just draw it again right here. the vertex of this concave or this opening down parabola, that's the value of it. Okay, now remember, the x value replaced the t, and the y value replaced the h, right? So the t represented time, and the h represented what? The height of the stone. Okay, so now what is the question? Determine the time at which the stone will be at a maximum height. What is the time? There you go. What is that? 1.02 seconds? Yes, seconds. Time in seconds, right? So this is 1.02 seconds. Determine the maximum height. Okay, what was the maximum height? Very good. So 105.10 meters, right? See the meters up there? Okay, so it went up 105 meters in like 1 second. That's a lot. Okay. Now what? Determine the time at which the stone will hit the ground. Well, you know what? This is something we're going to need to do on the calculator, and I can't get the calculator in this recording, so I'm going to pause this recording for a second. Okay, so when we're talking about the stone hitting the ground, okay, so I'm recording again. When we talk about the stone hitting the ground, okay guys, we're recording, okay, the stone is going to hit the ground when the height is what? When height equals 0. So, when you look at your ordered pairs, which are time and height, then this means the y value is 0, right? So when the y value is 0, this is your x-intercept, which is called the 0 of the function. So if I look at this lovely equation, y equaling a negative 4.9x squared plus 10x plus 100, and I replace the y value with 0, how fun is this going to be to try to solve? Not very fun. So what we do now is we graph it on the calculator and we trace the line to see what that value is at the x-intercept. Okay, so here's where I'm going to have to pause for a minute. So when we come in here and graph it, what we take note of is that that parabola looks like this, and when we get that point by tracing our graph, we are approximately at a 5.64 on our x value when our y value is 0. So it's going to hit the ground when the y value is 0, and the time is approximately 5.64 seconds. Okay, now that's hard to get that exact to the 100ths, but we are really close. Okay, that's a pretty darn good value. So that should answer all of those questions. But the most important thing I need to say again is they're going to be asking you to either maximize or minimize, and so your focus is on getting the vertex. Okay, so let's try another one. A quarterback throws a football, and when they do, it's in the shape of a parabola. The path of the football is in the shape of a parabola. A quarterback throws a football with an initial velocity of 72 feet per second at an angle of 25 degrees. The height of the ball can be modeled by that lovely equation. Okay, so h is height. It says here your h is your height, and your t is once again time in seconds after he releases it from his hand. Determine the time at which the ball will be a maximum height. This is my vertex. Because it's a negative leading coefficient, we know this is opening down, so the maximum height will occur at the vertex. And then it's going to ask, time just like the last one. So I'm going to come in here and rewrite this as y equaling a negative 16x squared plus a 30.4x plus 5. So then to find the x value of my vertex, which is negative b over 2a, my a is a negative 16, and my b is this 30.4. So you're definitely going to want your calculator to get this to the 2 decimal places. So this is a negative 30.4 over 2 times the negative 16. So right now the negative over the negative is going to be a positive result. So go to your calculator and you can just put 30.4 divided by 2 times 16, which of course is 32, and come up with 0.95. Okay, so the vertex, that maximum, has an x value of 0.95. Your y value says take that x value of 0.95 and put it back into the equation. So a negative 16 times 0.95 squared plus 30.4 times a 0.95 plus 5. So carefully put that into your calculator. So a negative 16 times 0.95 squared plus 30.4 times 0.95 plus 5, and I come up with 19.44. Is that what y'all get? Okay, so this is a 19.44. That's your vertex. So looking back at the equation, when we wrote it, we replaced the h of t with y and the t with x. So the x value is t and the y value is h. So question 1, part A, determine the time that the ball will be at its maximum height. What is the time? 0.95 seconds, almost 1 second, just shy of a second. Determine the maximum height of the ball. (19.44 feet). That's not very high. 20 feet off the ground? He must have been throwing it hard and fast, right? A lot of velocity on that thing, not going very high. Okay. Determine the max amount of time required for the ball to reach the receiver's hand if the receiver catches the ball at a point 3 feet off the ground. Think about this. There you go. Somebody said it out there already, right? So if you visualize this graph, he throws it, it's not going up very high, and it's coming back down. It's not going to hit the ground if the receiver catches it. And he's catching it about waist level, chest or waist level, bent over. And so this point has a y value of 3 feet above the ground. So part C says, go to your calculator and graph this equation and look for the point where the y value is 3 on the calculator. So when we zoomed in on the calculator over here, playing around with it, we had to zoom in several times. This point that we came up with became 1.96, and this was a 3.03, which is close enough. So when the question says determine the amount of time, part C, determine the amount of time required for the ball to reach the receiver's hand if the receiver catches the ball 3 feet above the ground. What is the time? 1.96 seconds. So he didn't get very far, did he? He didn't run very far from the quarterback in 2 seconds. So that's why it didn't get any higher than 20 feet. It was a short pass. That's really interesting stuff, and that's legit stuff, people. That's pretty legit kind of stuff. That's really good information. So this is 1.96 seconds. All right, so here's one. The monthly profit for a company that makes decorative picture frames depends on the price per frame. The company determines that the profit is approximated by this. I don't know why they put f of p. I wish they would have put p of x. But this function, this y value, is your profit. Okay, that's the money you make. So where p is the price per frame, and f of p is the profit. So f of p is the profit based on the price. So if I write this as y equaling a negative 80x squared plus 3440x minus this huge number 36,000, then y is my profit in dollars, and x is what? X is replacing p, so x is what? X is my price per frame. Okay, so find the price that generates the maximum profit. This is an x squared, this is a negative 80, this is opening down. And so the maximum will still be my vertex. Okay, so here we go. To get my vertex, my x value of my vertex is negative b over 2a. Okay, so this is a negative, this huge number, 3440 over 2 times a negative 80. So a negative over a negative is a positive, and so this becomes 3440 divided by 160, which is 21.5. That's the x value of my vertex. The y value of my vertex is to take negative 80 times 21.5 squared plus 3440 times 21.5 minus this huge 36,000. Okay, so negative 80, I've got a terrible glare up here on my calculator. Negative 80 times 21.5 squared plus 3440 times 21.5 minus 36,000. And I got 980. There is the maximum point, which is the vertex, when I graph that function. So what are the answers? Find the price that generates the maximum profit. What is the price of the picture frame? $21.5. So $21.50 is what the price tag should be on the picture frame to maximize his profit. If he makes too many frames, maybe his price of materials outweighs his price that he's going to get when he makes the profit. What is the money he's going to make when he sells those frames? $980. And so the $36,000 could be like the price of the building or something. You know, his cost. That huge number, 36,000, has got to have something to do with his cost in the process of building these things, his labor and everything else. Okay. So the big thing here is how to find the vertex, and then being sure you know what the x value represents and the y value represents in this example. One more, number 4. The gas mileage in miles per gallon for a certain vehicle. So miles per gallon, that's kind of an important thing, right? Miles per gallon with gas prices, they were really high, can be approximated by this weird looking equation where x is the speed of the vehicle. All right? So the m of p, which is the y value, is miles per gallon, meaning my little smart car gets about 40 miles per gallon. Okay, my Expedition gets like 15 miles per gallon. So that's what that is. That's kind of the goal, is how good a gas mileage can we get. The X is the speed, how fast, if you can, like if I put it on cruise control and I set it at a certain speed, it's telling me what speed to set it at to ensure I get the best miles per gallon. Okay, that's what this is calculating. Okay, so it has an x squared, so it's a parabola. It starts with a negative number, so it's a opening down parabola. So my vertex is going to be the max. All right, so I'm going to take it out of function notation, and I'm going to go back into x's and y's. And these are uglier numbers. So we've got to be really careful putting this in the calculator. So the x value of my vertex is negative b over 2a, which is a negative 2.688 over 2 times a negative 0.028. So a negative over a negative is going to give me a positive result here. So 2.688. So the reason I say that is I'm not even going to put the negatives into my calculator. I'm just putting the numbers in. And I come up with 48. Did y'all get that?
Oh, yeah.
I got an even number 48. Thank you. Okay, so my y value is a negative 0.028 times 48 squared plus 2.688 times 48 minus 35.012. Okay, so carefully put this into your calculator. Negative 0.028 times 48 squared plus 2.688 times 48 minus 35.012. And I do that wrong. I got 47.93. Is that what y'all got? Anybody get that one as fast as I put it in?
Yeah, I got 29.5.
You got 29.5 on the top one? On the bottom one, on the y value? Okay, I probably typed it in wrong. 29.5?
Yes.
Okay, very good. Okay, so here's my vertex. 48 times 20 and 29.5. Okay, 48 is x, 29.5 is y. What is x? Speed. So this is how fast the car, that's not very fast, right? That's the most economical speed to drive your car on cruise control. You better not be on the interstate. Okay? And the 29.5 is what? Miles per gallon. My smart car has them beat big time. Right? Okay, so to determine the speed that would get the maximum gas mileage, the speed would be 48 miles per hour, and the gas mileage would be 29.5 miles per gallon. Okay, so that's a very applicable example. So remember, the word problems look bad. Just find the vertex and you should be in good shape.